Okay, hi everyone. Welcome to the working group Node Lifecycle. Today is September 15th, and we have two topics on our agenda. So first, is there anyone who would like to introduce themselves? Yeah, we already had Doug, so welcome here. Okay, so unless there is no one else, we can start with Jean. Is that correct?
You can call me JP. It's gonna be easier.
Okay, JP.
Yeah, the first name is very hard to pronounce. Sorry for my parents didn't think of English when they choose my first name. So you'll have to make do and call me JP instead.
No worries.
Um,
Yeah, I gave you screen sharing, so if you want to screen share something, yeah, please go
yeah,
ahead.
yeah, if you don't mind, I'll do that. I just saw the option, and I think if I'm clicking on this, you should see some kind of slideshow. Who doesn't love Office, right? Can you see the screen?
Yep, we can see it.
Yes.
I
Can
can
you
see
hear
it.
me well? Okay, great. So yeah, as I mentioned, I'm JP, Jean-Philippe in French, but JP is going to be easier. One of the QD maintainers. I work for TLS. Shameless plug on the first slide, so this way it's out of the way and it's done. So TELAS is selling consulting services for Kubernetes, OpenStack, and other distributed systems, engineering, technical, or leadership expertise. TELAS is a deep lover of open source and wants to continuously contribute on open source. One day, I hope I will be able to pay the bills with by maintaining open source software with Telas. But hey, one can dream, right? So now that the shameless plug is over, allow me to introduce the topic first. QD. So what is QD? So QD is a daemon for rebooting Kubernetes node. The Node Lifecycle Working Group may want to standardize and clarify Node lifecycle behavior. So it seems like a good fit, and that's why I'm here. The value proposition is to provide expertise in code, get practical alignment between a simple tool like QRD and the broader Kubernetes coordination efforts. So the first step is to talk about QRD itself. So what is QRD? So it's a CNCF sandbox project. It's used for OS or kernel updates. I mean, in the context of OS and kernel updates, it's vendor or distro independent. The key features are watching a Sentinel file or command to detect whether a reboot is required. Locking to ensure that only one at a time or maximum n nodes at a time reboots. So this way you don't disturb the whole infrastructure at the same time. And extra features like sending notifications on events, requesting Prometheus to decide whether a reboot can happen or not. So QD started with a very simple daemon set. So sorry if I kind of changed the name of the presentation. So I used to call it past, present, and future of QD for this working group. But I realized that when I was writing this presentation, I would more call it present and future because past is so long. I realized that I needed to skip a few things of the past. So, but I will still talk a bit about the past if you don't mind. It started as a very simple daemon set, but it grew over time for any single use case. For example, hey, I wanted to label X at this point of the reboot process. So I initially, as I mentioned, I wanted to list all those oddities in this presentation, started with explaining what the past was and all this history of all these changes. But then I realized the presentation would be too long and not easily processed. So if you don't mind and want to know more about these histories and those weird edge cases, don't hesitate to spend time with me and I can go through all these git log and all these kind of weird stuff that was not easily expressed. But I think it's worth going one at a time. because not all of them are recorded as end-to-end test cases in our project. Anyway, so why QD matters? It's technically keeping your Kubernetes nodes updated is essential for security and performance. At least that's what I believe. QD automates this process, ensuring that your nodes are always running to the latest and most secure software. And QD reduce the human errors, save significant time in terms of you don't have to do it manually on your clusters. So there are many alternatives in the community. I don't mean that QD is, I don't know, more important than others here. Just one example of a pattern that needs to be applied for lifecycle of nodes in a Kubernetes cluster. And that applies even if you have immutable nodes. At some point, you need to know when your nodes need either rebooting or deleting, if you're working with a cloud provider. And well, you need to know how to act upon it. So you need a certain, I mentioned you need a certain coordination if you don't want to reboot all your nodes at the same time. That's also an important feature. And I think if I would summarize this, QD is particularly useful with bare metal workloads. AI workloads, which tends to be more stateful, or cloud provider, which don't publish updated image fast enough for you for certain people's needs. Okay, so that's the present. Now let's talk a bit about the future. So we have a plan for QDV2, which has been documented for months now. It's on this link. I'm not sure if you see my pointer. So anyway, this plan we had for months now, and we started to crystallize it in the last community meeting. The idea is that I plan to split QD into multiple components, mostly to improve security of QD. It will require redefining in the interfaces between those components, and this will allow to reduce our tech debt and increase our agility and ease the maintenance over time. All those components, they could, I think we could reuse some of those codes for certain people that would be interested in node lifecycle management. Anyway, I encourage you to challenge this design at the end of the meeting. I splitted the meeting in multiple sections, and the last section is discussion and actions, so we can discuss that there. But long story short, the idea here is to split between the detection of a reboot, the reporting of a reboot to the API server, then schedule when you need to have your maintenance schedule, do something. For example, on the node, put a certain condition there, like under maintenance. So the reboot executor, which will eventually become a job, can read simply the API server, know, okay, I'm now under maintenance. It's been all coordinated. I need very simple read access, and I can trigger my reboot. So at some point in QD, that would be very nice and very simple. As you can guess, it won't work like that. And there are multiple stages where the reboot executor will most likely fail. And one of it, I'm expecting, will be solved by this working group, which is for example, the declarative drain, or the declarative eviction, depending on how we call it. This is part of the executor to drain the node and then trigger the reboot. So depending on how we do it, we will have to think about that. But that's already one interface. But the other interface that I think could be useful is all these interfaces, for example, conditions that I'm mentioning here. I'll explain that later. So let's talk about more in deep details about my expectations for the collaboration between the working group and QOD. So first, QOD needs this working group because while QOD v2 rewrite that I just mentioned makes sense for QOD, it still leaves us in a place as where we are, which I mean that, for example, the CNI or the CSI, they will still behave the same way if we don't change the code. And I believe that this is one of the reasons QD adapted its code over time is for the specific environment and ecosystem thing. So it was not in the CNI or it was not in the CSI. So QD did something. And I believe this is not the right place to fix issues. I believe that QD should be a very simple thing. And to do that, things need to evolve in the community. And I'm not expecting the community to move by itself. So even if I moved QD to a very simple thing, a very simple model, the ecosystem will need to adapt. That's my understanding. So in other words, because our audience is not developers, they're sysadmins mostly, sorry, um, the value that people will see for end users will only be perceived when the more of the ecosystem components will be using this working group recommendation. So QD will follow the working group recommendation, but it's not enough for me. It's I mean for the end users, it's should be more than QD to follow these initiatives. So what would QD bring to the table? Because now I'm saying what QD would take from this working group. I think that it's fair to say that QD should bring also something to the table. So I would say part-time developer, which is already useful, but I think the most important is the history and those edge cases that I was mentioning. I think those are useful to share, especially since our very old, I would say very long story, though it's been less active recently because we are quite feature stable, but all these edge cases are very, I'd say very weird. I can think the one that I can think of, a recent one is like someone had to ship Kubernetes into some place. It's on a boat. So when the boats move to some different places, it changes time zones. And when you do this, it changes completely your maintenance. And all of this has ripple effects. It's fun stuff. Anyway, long story short, I'm here to share history. Um, and if possible, my time, if you would be welcoming that. Um, so for me, this working group is a blessing. Um, covering standard life cycle, covering standardized life cycle signals and behaviors is very good. I read long ago, well, I can't remember when now, sorry. It was an issue by Tim Hawkin. He mentioned the lack of comprehensive node lifecycle documentation or lack of follow-up of the tools that we have at our disposal in Kubernetes. He said what we want is a clear signal that this node is going away and a way for third parties to indicate that they have work to do when that happens. It was one very specific case. And he said, we have that. And I think that most of the things we have in Kubernetes will allow us to improve node management, but we stopped at certain point, and I think this working group is going to be like the next inductor to move to the next level. And so when Tim wrote, we have that, and he mentioned this node is going away because it was for cluster auto-scaling, I think, and it was for nodes that were deleted. I think this can be extrapolated to not only a node going away, but something happening on the node. And so I believe that there is tons of life cycle signals that should be shared. I believe this working group is an opportunity to clarify those things and start to move towards a clear direction, implementable for many controllers impacted by node lifecycle events. Without a common lifecycle model, tools tool behaviors might conflict or be non-deterministic. And sorry if I'm not always watching the camera, because you are here on my screen, so you're here on my right. So it's I don't want to be impolite. It's just it's just usual thing.
No worries.
Anyway, I will give you a few examples of things that I consider could be solved with this working group, which would be the and that would have an impact on QoD, which is, for example, the autoscalers. They are reacting to node lifecycle events that will destroy some nodes. And QoD right now, it relies on locks. When you are deleting a node, you are not necessarily deleting a QoD lock, because the QoD lock is not necessarily on the node itself. So we should be watching something happening and know, okay, the node has been deleted, so now I can do things. That's just one example. One of the other example would be the CNI that would be able to stop announcing routes exactly at the right time during a maintenance, so we would not need to have this code. Another would be the PDB that will not block administrative maintenance. We already discussed that. Another would be volumes would be U-mounted on the system at the right time. Those are useful signals. And standardized signals will reduce bugs and edge cases, or simply reduce custom code across the different tooling layers. Because if you remember what I said earlier, I said QD is just one example of tools like that. I believe that everything we did in QD is most likely implemented in some other controller that deals with node lifecycle events. Because I'm checking there is code for I check there is a controller at Rancher at sorry SUSE now. There is a controller at Red Hat, and they are doing about the same thing. So I believe that there is huge opportunity to work together. Anyway, I'll go to the last section, which would be the discussion and action. For me, the discussion starter and action points are far more important than all the things I just mentioned. So for me, what I would like to take from this working group is to know, is there any of you who want to first define node lifecycle conditions that would be reusable and build some precedent for other controllers? This way, I'm not creating my own for QD and it will not be used by other controllers, because QD would be like an implementation that would be specific. And so first, is there any interest there? Second is, do you want to work on a single way to officially soft prevent scheduling on certain nodes needing maintenance for large clusters? This is another QoD thing that is also involved with a node lifecycle event. And three is, do you want to work on a single code base somewhere? Because if I'm splitting certain components, some of those might be reusable. And well, I'm trying to gather interest here. So if I were to give an example of the first item, which is, do you want to define that? I have a few example conditions for which we could get started, but if you don't mind, I will stop speaking now and I will take questions. Oh, I see a hand raised.
Yeah, Lucy.
Philip, do you want to go first, or should I jump in first?
Go ahead.
Okay. First off, yes, thank you for the presentation. Very interesting. Have you had a look through our declarative node maintenance cap? Because I see, yeah, exactly. I see a lot of mishmash between these two things, especially around what is it? Around how we can set a standard here, and then controllers can then implement and work off that as effectively a contract that finally everyone can agree on, rather than there being 300 implementations of how to shut down a Kubernetes and upgrade a Kubernetes cluster out there. So yeah, at least on one, that is the first thing I wanted to say. I have other thoughts, but before that, other people have their hands up, so I'm gonna be quiet for a bit.
So I'll jump in. I wanted to, thanks for the presentation, JP. I think I want to add to that first question you asked about the node lifecycle conditions. We had spoken last week about it a little bit, where we talked about this idea of possibly adding some conditions to the node. Today it's like ready and not ready, and talking about we were throwing around the idea of having a draining condition and a maintenance condition on the nodes, and there's some additional discussion about some other conditions. So I think absolutely, like there is room for doing this, and there is definitely some interest in doing this, and I think where we are is like we're still talking about it. I think our next discussion point is we wanted to gather some feedback from everyone in terms of what those conditions would look like, and then tie it together to the existing node maintenance cap and the eviction cap, and to see how these things will all um, work together. So I see you have it here. Like these are your suggestions for node conditions, which would be interesting to talk through.
Thanks. Love it. And sorry I missed last week meeting.
Yeah, no problem. If you get it should be recorded. If you're interested in seeing the discussion about around this, if you want some of the context, have a look. I think you might find it interesting.
Yeah, we
Cool.
spent pretty much the whole of last meeting discussing.
Oh, I'm sorry.
Don't worry about it. The recording's on YouTube. It's all good as well.
Yeah, the short story is that we are trying to bring back the non-maintenance cap back to life. So it has been in a stall condition for quite a long
It's a tough
time,
one.
and yeah, it is. And yeah, and basically we need a consensus on that, what to do. Like it is easy to just like come up with anything and just like but we need like there are higher standards for this kind of thing to like if we want to introduce it to Kubernetes. So yeah, we certainly would like your feedback or anybody else's feedback. And yeah, thanks for offering your collaboration. And so yeah, I guess like we've had like some discussion last week. We also did some side conversations. So I guess we could maybe start a doc and try to start simple and just try to sketch like the states like we would like the to observe or expect the node to be in, or the node maintenance or the states of the node maintenance or of the node, and then we can reconcile this to something which suits everyone.
Yeah, I think the AI is on me right now. The action item is for me to put together the diagram. So I only talked about two states last time. I said it was draining and maintenance. I'm sure there are more, and so I think what I was planning to do is put together a diagram with just those two, and then I wanted to hear what it would look like, when like with your opinion, JP, and like there are others probably out there to see. And then specifically, I think the hardest part is like tying this into the node maintenance cap. Like when we have these conditions, what does it mean for the node maintenance cap? And then we should also see when we do that, it should tie into the eviction cap, right? So the AIs and me, I'll have this week. I'll have a diagram for this, and we can talk about it on Slack, and then return to this meeting probably in a few weeks and go over any feedback. So that's the current plan of record.
I like it. Thank you.
Yeah. Okay. Yeah, we can wait a bit, but I think it would be also good to see like what like other solutions have like would like to see in those like the states they would like to see. So yeah, we can see the diagram, and then we can start like the conversation and diverge it from there. Yeah, Michael?
Yeah, I just wanted to say thank you to JP for the presentation, and to kind of respond to one of the questions that JP was asking. Yes, I would absolutely love for this collaboration to be happening between all the parties involved, and I would love to see it out in the open, where we can all kind of participate. Um, I wanted to bring kind of, another perspective to this, which is that we're currently working through some very difficult problems in the SIG autoscaling and SIG cluster lifecycle communities around like node upgrades during like autoscaling events and whatnot. And one of the things we've talked about in several different perspectives now, or several different conversations, is that having some sort of synchronization like these node lifecycling events would really help the autoscalers and the cluster lifecycle components to know better when to back off, right? Because one of the things we're experiencing right now is that, you can imagine the cluster autoscaler works on many different platforms. Some platforms provide the ability to do like node maintenance and node upgrade while the cluster autoscaler is running. And without a way to synchronize around what's happening on the nodes, this leads to extremely deleterious effects in the cloud, or it can lead to. So I applaud JP. Thank you for bringing this forward. I would absolutely love to see more work done on the node lifecycle maintenance cap as well. I think it would really help out many, many groups of people. So thank you.
Yeah, I think. Oh, sorry, really bad time to cough. No
worries.
Yeah. I think maybe we should have a look at Kyuri. Is that how I'm saying it right? Or is it just Kyud? And
Doesn't matter.
whichever one it is, whichever one it is, I think maybe we should have a look at that and see how it's being used today, and maybe use that to inform declarative node maintenance as we continue to effectively revive that cap. Maybe we should how should we start this track? Maybe can we put something in future agenda to revisit this exact thing? I'm happy to write it in our future list. Cool, because I don't want to drop this. Okay, cool. That's what I want to say.
Yeah, we can certainly put it to the agenda and make sure to come back to this. Yeah.
When we do this, do we intend to, for example, ask very specific tasks to certain people? For example, please gather all your IDs of node conditions. We put that there, or we put that at a different point? I'm confused about how it's gonna pan out.
Yeah, I like, yeah. Okay, Ryan, please go ahead.
I think, I mean, I'm open to like how people want to do this, but I mean, the way I was looking to approach this is that uh, I was gonna try something like very simple with the two conditions that I had thought of,
Okay.
and then try and I want to weave this into the other caps. I think that's like one of the hardest parts of this is like weaving this into the other caps. And part of the reason for that is like we're talking about reviving that maintenance cap. I think part of reviving that maintenance cap is we need to see the whole picture. So I think these conditions are an important part of the whole picture. So I think I'm going to start very simple and like just a diagram with a few conditions on the node, weave it into these caps, and then I'll post it in the Slack group and for the working group node lifecycle. And then I mean I would just want to hear feedback from people and would be great to spend time in future meetings talking through the diagram and like I said, I really want to hear, it would be great to hear arguments like your perspective on node conditions and why you think those conditions that you had listed are important and what you use them for, your use cases and stuff. And then from others as well. Like I think there's going to be quite a few. I mean, I've already heard quite a few people have been talk about this idea in different forms. So it'd be really great to see and see if we can align on what we think are the conditions that are important for success.
Okay, so if I got that right, it means that the first step is really yours, and then starting to take with the minimum set, and then probably in a later phase, like to compare the nodes.
Yeah, it's just so we can have a picture to work off. It's really like because we don't. I think it's this is complicated. So I want to get a picture in front of all of us, and then we can kind of work off of that picture. Yeah, and it's like you said, compare notes.
Makes sense to me. If you need help, just don't hesitate.
Sure. Cool. Thank you.
Yeah, I'm totally for iterating on the final solution, but I think yeah, like for like posterity purposes and to actually see like where we started, I think it would be useful to actually like track like different projects like what they have in mind. And so, for example, what like the cured would or cured would benefit from. And so I guess like what do you think, Ryan? Like that we could like start a doc and like
Yeah.
make a tab for cured.
Yeah, I
And
agree. I think I'm,
yeah.
oh, yeah, I'm sorry. I honestly, yeah, I agree. I think because I think really where we're going with this is I think these conditions are going to become a cap. I think that's like the goal. And I think we need this exactly like you're saying, Philip, is that we want to have the projects and why they would want these use cases, why they're valuable. And I even wrote down a few of the things you articulated, which is like you making tools deterministic about lifecycle states and then having a lock for a controller and of who owns a node, like really important arguments as to like why these conditions matter. But yeah, I agree. We should have a document and we can Curd can have its use cases in there. I'm happy to start that and we can, while we talk about this diagram in parallel.
Yeah, cool. Yeah, JP, just don't like overburden yourself. You can just start by putting the conditions you had in your presentation there. It's like so we have something like to work with, or something you have in mind for Cure the V2.
Perfect, will do.
Great. I'll share the document when I have it and we can work off of that. Thanks, JP.
Okay. Cool. Sounds great. Yeah, just one quick questions about the V2 version. Like what is your plan? Like, are you like looking sideways like what we are doing, and you have some set of features that you would like to introduce, or are you waiting for us, or like how do you see the like our involvement or the development of the V2?
So one of the things I can already start is the refactor of our code, which is, like I said, big monolith, and all of this would be split into multiple subcomponents. If I were to split those components, I would rely on conditions, but I would make them efficiently. I would make them variable. So at some point, if I were to adapt to a new model, I would just use the standard conditions that we would implement. And for the extra conditions that we would have, it would be QD specific, so that's fine, right? So I think that this is not, I would say, it doesn't prevent any work from QD perspective, and there is no deadline because QD is in maintenance mode. I mean, it continues to be maintained in V1. This V2 is, I would say, an objective we have to reduce the tech debt and to improve the security, but it's not, there is no one like paying me to do it right now. So it's just a labor of love. So it will take time, and I'm fine with that. And if someone wants me to do it right now, well, the first reaction I would have is make sure you're also involved into this working group.
Sounds great.
So don't worry.
Yeah, I think that's like it's a great step to actually like see what's the intersection in the community, what we would like to see. Like even if we just use the conditions, or like as you said, like like from your perspective, when you are not introducing something to kube core, like the conditions are like one of the main approaches how to extend on the API from your perspective, which is like any actor can do that. But we are looking at these conditions or like status or states like in an abstract sense. Like we are trying to define like a kind of state machine or like a set of transitions that like the community would expect. Like I'm not
Yes.
saying we will do it like that. Maybe we will not have like hard dependencies in our model, but yeah, we are just trying to see like what the community would like to see, and yeah, and then we would like to encode it in the API. And the API possibilities are either like through the new API, the node maintenance object, or in the node API in the node status. So yeah, there are kind of like a bunch of possibilities, but yeah, but we are looking at the raw like picture of like what's what
I,
you would like the states to be.
I didn't mention the full picture indeed when I mentioned here what I could do for V2. I think parts of the pain that also comes from QD is not only on those conditions as you can expect, and so the caps that we already started to discuss are also a very important part. I don't want to continue to do kubectl drain and have all these kind of problems. So I think that it's multiple facets that comes into QD. It's just that what I wanted to highlight here to answer your initial question was you don't have to worry about QD. QD could be trailing or helping on the way, and so working together. So this way, we, for example, if we were to implement certain things, we would be a first implementation. And I know that V2 of QD is going to be very disruptive because there is a reason why I want to call it V2. It's because we learned all these things from the past, and it's going to be disruptive. So I know that in IT, it's a terrible idea in general, but I believe that this is the right way for the project. And because it's disruptive, we can allow more time to think about things and to work with you. And well, if people don't use V2, that's also fine, right? I really, at the end, I don't have a say into how people are using software. It's the way. It's just that I'm gonna work on something that I believe is the best for our case.
Okay, sounds great. Thanks a lot for your presentation. Yeah, we will have to move to the another topic. Just please put like any useful links into the agenda, mainly for the V2 or your presentations if you want to share it.
Yeah,
And
will do.
okay, cool, thank you. And we will give the ground to Doug. I will enable the sharing for you.
Yes, all right. First of all, I just want to say GB for the presentations. It was very interesting that we have also other people interested in this node life cycle. We also interested in this project. We come from Uber, and we also want to. We share the same pain, and we want to contribute to this open communities so that we can solve one problem together. So for my presentation today, I'll present one, I think, working implementation of the eviction request API. So this is just my own implementations. Hopefully it will it match the cap itself. And yeah, I'll share my screen with the yes. Just want to ask if you can see my screen here.
We can see your terminal.
Yes. So For my demo, I have set up a local client cluster running with the controller and the webhooks defined in the CAP. And in this demo, I want to show two things. The first thing is that when we create an eviction request, there is a admission controller that pass the port annotation about the interceptor that they interested in the termination of this port. So this webhook will pass the port annotation and then put it into the eviction request interceptor spec. And the second thing is the actual evictions of the port itself. So let's go with the first one. First thing I want to show you the content of the port here that I'm going to create. This is the thing that we're interested in. The annotations. This annotation tell the webhook that this is the actor that wanted to participate in the termination of a port with a priorities of 100. As in the CAP that we have a range of priorities, but I'll keep it at 100 here for now. And now I will create this this pod. Okay. I need to use this first, and then yes. Sample pod. Where is it not found?
Did you create the namespace?
Okay. I forgot to create a namespace for it. Yes. And here we have the pod running here. I know it's still in container creating state. Here now it's running. Here, the first step, I want to create an eviction request, and we can see that the interceptor is passed correctly. For the eviction request itself, I want to show you the template that I'm prepared here. So the most important part of the spec of eviction request is this port reference. We need to pass in the UID of the port that we want to evict. So I need to take this out from the port I just created. So I have this one prepared so that we get the the port ID of the port that I just created. So this is the ID we got here, and then I'm going to create I'm going to replace this port ID I got into this template and then create the eviction request. Now, yes. Now is this eviction request itself. After it created, we have this spec created with a list of interceptors passed from the node from the port annotations. You can see that the class of the interceptor is actor a.uber.com and the priority is 100 as we see in the port annotations. So this is the thing that we cared about. Is it passed correctly? And then the status here is updated according to the highest priorities interceptor, which is in this case we only have one, but from my implementation we can have multiple. So the active one now is the actor A, and the condition is that it is working, so intercepting this eviction of a port. Yeah, that's yeah, this the first thing that I want to show is working. And the next thing is about the interceptor itself, where it heard beating and then updating this eviction request saying that it finishes its work and then it can allow the port to be deleted. I don't have that working because it's just a simple implementation. So I'll just using a kubectl patch command here to patch the status of this eviction request with the interceptor completed set to true, so that the controller can move forward with the eviction process. Yes, and then I have patched it with the with a stated here. You can see that it reported that the eviction request has succeeded now, and then the port is deleted. I think that's the whole. I can show you a bit of a log from the controller here, and it's waiting for the interceptor to progress, and then when all the interceptor has completed, it going directly with the eviction. So it call back to the API and delete the port. After it finishes, it reported back that the port has been evicted successfully. That's the end of my demo. And now we have time for some questions.
Yeah, it was great to see. Finally, the implementation of the CAP is coming back to life, or is coming to life.
Yes.
And yeah, that's a very, very good work.
Yes, thank you. Yeah, I'll try to follow the cap as close as possible so that we don't have to change it much when we want to push it upstream. Also, this implementation, I try not to have any dependency on Uber internal tooling. So this is just for client Go implementation, so that when we merge upstream, I think we don't have to change much, and hopefully we can push it soon.
So the implication here is that this has been written in a way where it's not dependent on Uber's stuff at all. And so one of the things that we think is quite cool about that, especially if it's keeping pace with the KEP, is that when we want to do an alpha of this controller in Kube Controller Manager, it shouldn't be that challenging, for example, to take Duck's work.
I'm sorry, my sound came out.
Uh-oh. Do you want me to repeat that? I'll repeat it. So, and this is one of the things that is quite interesting about this to me, is that because this is not dependent on any proprietary system, and it's keeping pace with the KEP as we work on it, it means that if we want to do an alpha of this controller in Kube Controller Manager, once the KEP is agreed on, then it wouldn't be, in my opinion, too challenging to take a lot of Duck's code and reuse it in a K/K for the Kube Controller Manager.
That's cool.
Yes.
Sorry, I'm back here.
Did you hear what I said at all?
Sorry, not at all.
Okay. You know
sorry,
what?
my
Third time is
battery
the
in my
charm.
yeah,
Yeah,
battery in my headphones just got drawn, and
it'll be on the YouTube. How about that? But basically, TLDR of what I said is we can use Duck's controller code in K/K because it doesn't depend on Uber code and it conforms to the cap. That's the TLDR.
Yeah, I will see the recording. Thanks, for the details. Yeah, I have just like a couple of points regarding the cap. Yeah, I think like in mostly it will stay the same or similar, but there is like one pending review from Joe, which I still have to address. So we will, for example, like to use the annotations in the bot API like directly. And like there is a couple of bunch like a small things that will be changed, but like the main concept will stay the same. So and yeah, I hope that's not a big issue for you. And we will also probably like to use your presentation and like link that you have done the implementation like even before the cap is merged. And I suppose like you have still not been using that internally, right? Like it's too soon. So, but do you have like have you considered like trying to use or like make use of this solution for some of your tools, or like to test the interceptors or the switching, etc.
Yeah, we plan to use this controller as one of our I think migration of some sort to the Kubernetes stacks, and yeah, I think we definitely want to try it out.
Yeah, so eviction request, whether it lands or not, whether it's in Duck's implementation or upstream, is a core part of a migration that is going on inside Uber of our stateful, so database-based technologies from the proprietary system they're on right now into Kubernetes, and it is a non-negotiable part of that migration plan. So inside Uber, we've already effectively committed to using this API object.
Whoa.
Yeah, we're bold.
And where is the code at the moment? Is it already open sourced in public place on Uber side, or?
No, this is our internal code space only.
Okay.
But once the KEP merges, we can very quickly make a PR to Kube Controller Manager to do an alpha of this.
Okay.
Like, because the code doesn't depend on Uber, we can just one-to-one copy most of it.
Yeah, that's very great to see. It like the main part is merging the CAP and like getting the consensus on the CAP. So I will propose this for 135 in Signode, and and update the CAP, and we will put like some summary of what you did in Uber and what like you are hoping to see.
I have a one-to-one with Dawn Chen, who's the tech lead of Signode tonight, where I'm also going to bring up that I think we should target 135. I believe she's been reading the CAP over the last week.
Okay, great. Yeah, I will try to make the CAP up to date as soon as possible, and yeah, we can try to progress there. Thanks.
Thank you.
Yeah, is there does anyone have like final questions? Okay, cool. Thanks everyone for presenting today, and hope to see you next time.
See you next time.
Thank
you,
you.
everyone. Yes, see you.
Have a good day, everyone.
Thank you.
Bye.
You too.
Hi, good day.